Here are solutions to homework set number 4 for ECE 376 Embedded Systems. This homework set looks at C programming and the LCD display. Now the first problem is, how long does it take C code to execute? So for example, if I have the following code, can I measure the execution time? Well, one way is to dig through the list file, that's the assembly listing, count assembly instructions. That's kind of painful. Another way is experimental. I'm going to take a pin, well, I'm just cutting on port C, connect that pin to a speaker or measure the frequency of the square wave on that pin. That'll tell me essentially how long it takes to toggle the pin. So here I took this code, compiled it, downloaded it, and I can measure on port C how fast is port C pin 0 toggling. It's toggling at 9.7 kilohertz. And if I move left, each pin is divided by 2. There's half of that. Next pin, half again. Next pin, half again. Now, if you don't have a voltmeter that measures frequency, I can also use a speaker and the Piano Tuner app on your cell phone. So here I've got a speaker connected to RC0 and ground through 200 ohms. This is the frequency on RC0, 9.7 kilohertz. I'm surprised you can see that. Divided by 2. Divided by 2. That's another way to measure frequency, which is kind of annoying. So here, measuring on port C pin 3, I measured 1218 hertz. I need to multiply by 8 to get RC0. The number of clocks per loop then is 10 million divided by 2 times hertz. Plug in the hertz is 1217 times 8, 513 clocks per loop. So, got a square wave coming in. That is this distance right here, 513 clocks. I toggle every 32nd time around the loop. So take that number divided by 32, I get 16. This right here is about 16 clocks. In assembly, I could probably do it faster. C is not quite as efficient as assembly, but that's counting mod 32. Doing the same procedure, if I count mod 35, it is now 252 hertz on port C pin 0. Calculating, it's 19,000 clocks for 35 loops, 565 clocks per loop. So notice it was 16 clocks to count mod 32, 565 clocks to count mod 35. Powers of 2 are much easier to work with than things that aren't power of 2. That's oftentimes, or why you oftentimes see in programs, people stick with powers of 2. It's just more efficient. Let's do long division. In C, I can add, subtract, multiply, divide. How long does it take to divide a 32-bit integer? Well, I can find that experimentally. I'm just going to go through a while loop, count mod 32, just like in part A. Every loop, I'm going to divide 2 integers. Measure the frequency on port C pin 0, I get 86 hertz. That tells me it's 57,000 clocks to go through 32 passes, divide by 32. This distance right there is 1,808 clocks. Subtracting 16 from part A, it's 1792 clocks to do a long integer division. So one instruction in C could be thousands of lines of assembly. Finally, let's do a floating point divide. If I do this code and just do a floating point division, here I'm not counting, so it's just every loop is my answer. I get 80 hertz. 10 million divided by 2 times hertz is 61,000. And this wasn't exactly my test code. I actually counted mod 32 in my test code, so taking that into account, it's 1,918 clocks to do a floating point division. So floating point is really expensive. Again, one line of C isn't necessarily one line of assembly. It could be thousands of lines of assembly. Problem 2. Let's build a lights out game. This is something we did back in assembly. Now do it in C. So here's how the lights out game works. What I do is on reset, I just count really fast on port C. When I hit RB0, that picks a random number, and that's my starting point. So I want to turn off all these lights. When I hit a button like RB, this is a pretty easy one, RB1, it toggles this light and its two neighbors. So press it, and there I got that. Hit RB0, toggles this light and its neighbors. Let's see, press this one, then this one, then that one. All the lights are out. And that took me hex 1101 turns. Let's write that program in C. So here's what the program looks like. I'm going to make port A, B, C, E output, port B input, initialize everybody to 0, everybody's binary. And now, here's my infinite loop. Well, forever and ever, I'm going to wait until I hit RB0, count really fast on port C. That's what you're seeing right here. On reset, it's counting really fast on port C. When I hit RB0, it kicks out, and there's my starting number. I'll wait until I hit a button. When I do, check which button I hit, and toggle that light and its neighbors. Count on port D, wait for me to release the button. So here, if I press RB1, I toggle those pins, and so on. The resulting code is 218 bytes, or 56 lines of assembly. Actually, 109 lines of assembly. That's half this number. In assembly, I wrote the same code in 56 lines of code. So the claim is that C is 80% efficient, 20% larger than assembly, which is a lie. C code is typically 3 to 10 times bigger. This one is 2 times bigger. That's part of the reason to use assembly. Assembly is much more efficient in terms of writing code, but it's a lot harder. The C code actually is pretty easy to write. Plus, if you had to modify it, this is actually semi-understandable. The assembly code was really cryptic. That's problem 2 and 3. Problem 4 to 8 is a magic 8-ball. So here's what the program's supposed to do. I've got my magic 8-ball programmed on here. I want to ask it a question like, are the Vikings going to win this week? I shake the magic 8-ball 3 times, which is simulated by pressing the button 3 times. 1, 2, 3. And it gives me my fortune. Ask again, will the Vikings make the playoffs? Shake, shake, shake. Very sad. Anyway, that's a magic 8-ball. How do you program that? Well, the program is kind of bottom-up programming. This is kind of one style of programming. Do it in chunks. This is one of the reasons to have subroutines. I want to write a subroutine where I pass the number 0 through 11, and it gives me the corresponding portion. So here I've got my messages, 0 through 11. Oh, here's the fortune, 0 through 11. My subroutine, I'm going to call it fortune. I'm going to pass the number 0 through 11, and then display it. I'll move to row 1, column 0. And then for 16 characters, write that character of the message. That's these guys up here. To check it, I'm going to try this routine. I'm just going to count 0 through 11, 0 through 12, and then display what I is, display the fortune, and wait. And what that does, that kind of goes through the various fortunes. Once I am happy that works, so here's fortune number 1, the result. Try the next level. I need to generate a random number. One way to do that is I'm going to wait for button push. So this is waiting for me to hit a button. Once I press it, it kicks out. Wait 10 milliseconds to avoid bouncing. While the button's being held down, count mod 12 really, really fast. Once I release, that's my random number. That's one way to do it. When I try that, I got the numbers 3, 5, 8, 8, 2. Numbers between 0 and 11. Looks good. Next, I want to count to 3. So I have to go press, press, press. Well, that's for loop. For I equals 0 to 3, I'm going to wait 10 milliseconds just to avoid the bouncing while the button's not lock up until the button is pressed. Once I press the button, wait 10 milliseconds, freeze while the button's being held down. Once I release it, come back. So do that 3 times. That's 1, 2, 3, kicks out. Finally, want to add a 5-second delay. So I get my fortune, and then it clears the screen. That'd be right here. I'm going to wait till I hit the button 3 times. Once I hit 3 times, I know what my fortune is. Fortune number n. Display it, wait 5 seconds, and repeat. That's typical in this class. I have this infinite loop. That's like a stoplight. When I build a stoplight, I want it to work over and over again, not just once. When I buy a magic 8-ball, I want it to work over and over again, not just once. So I can find out, will the Vikings beat the Packers this year? 1, 2, 3. No. Ooh, very sad. That's the magic 8-ball. So that is homework set number 4 for ECE 476. C coding and using LCD display. The LCD is actually pretty useful. I can get out a lot more information with the LCD than I can with just the binary outputs, such as you can display fortunes and find out, are the Vikings going to win this week? Homework set number 4 for 376.